Welcome to Lesson 73, Formulas for Sequences. Our objective is I can use subscript notation to find every term of a sequence. So you may recall that a sequence is an ordered list of numbers that follow a certain rule. So let's find the rule really quick of this one. So to go from, let's see, this looks like just the list of the numbers. Okay, so to go from the first number to the second number, looks like I'm adding 3 each time. So let's write a rule. A sub n is the value of a certain thing, and it looks like it's 3 times the index number, the number of the term, and I multiply it by 3, right? 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. So it looks like I'll be able to use that rule. So let's use that rule to our advantage. Find the 8th and the 9th term of the sequence generated by the formula a sub n equals 3n. So what I'm going to do is a is the actual value, n is just, it lets me know that a changes. That's why n is small. So it shows me that a is changing whenever it's the nth. So the 8th term of the sequence, I would write a subscript 8. And that's going to be 3 times 8. 3 times 8 is 24. So that's going to tell me that the 8th term of the sequence is 24. Let's find the 9th term. A sub 9 is going to be 3 times 9, which is 27. So the 8th and the 9th term of the sequence are 24 and 27. Go ahead and pause the video and try this one on your own. Now that you've tried it on your own, let's do it together. So find the 10th term of the sequence generated by the formula a sub n equals 2 to the nth power. So the 10th is going to be everywhere that there's an n, I just plug in a 10. I'm going to need a calculator for this one. 2 to the 10th power is 1024. 1024. That is the 10th term of the sequence. Let's try this next one together. Find the next 2 terms of the sequence. So to do this, I need to figure out the pattern. It doesn't say that we have to write it in subscript notation though, but I may do it anyway. Looks like 1, 2, 3, 4, 5, 6. Hey, look, it's the last thing we just did. So let's find the next 2 terms. Looks like it's doubling each time. So 64 times 64 is 128. And then it's 256. There we go. That's it. Go ahead and try this one on your own. This one's a little bit trickier. Okay, now that you've tried it on your own, let's figure out this rule. Looks like I'm subtracting 3 here, and then I'm adding 3, or adding 4, sorry. Minus 3 plus 4 minus 3 plus 4. So the next 2 terms of the sequence would be, if I minus 3 from here, I'll get 1. And then if I add 4 to that, I'll get 5. It's a tricky sequence. Very tricky. So find the first 3 terms of the sequence given by this formula, 1 plus 2 times n. So for n equals 1, a sub 1 is going to be 1 plus 2 times 1. 2 times 1 is 2 plus 1 is 3. So the first term in the sequence, is going to be 3. For n equals 2, a sub 2 is going to be 1 plus 2 times 2. 2 times 2 is 4, plus 1 is 5. And then n equals 3, a sub 3 is equal to 1 plus 2 times 3. 2 times 3 is 6, plus 1 is 7. So these are my first 3 terms of the sequence, 3, 5, and 7. Go ahead and try this last one on your own, and we'll see you in a second. Now that you've tried it on your own, let's do it together. So the triangular numbers, 1, 3, 6, 10. We've talked about them in class before, because it's one of my favorite sequences, can be found using the formula a sub n is equal to n times n plus 1 over 2. Let's find the 10th triangular number. So a sub 10 is equal to 10 times 10 plus 1 divided by 2, which is 10 times 11 over 2, which is 110 over 2, which is 55. The 10th triangular number is 55. Thanks for watching. I'll see you in the next video.